Hello friends, welcome to my YouTube channel Aviator Updates. If you don't know me, I am Rakesh Negi and I am an aviation enthusiast. In today's session, I am going to discuss about the operation of reverse current cutout relay. So let us start. So before we start friends, you should know that the reverse current cutout relay is used as a protection against reverse current. Okay, that means it provides an automatic protection against the reverse current in the circuit. Generally, it is used in small planes having DC generating systems. So to explain the reverse current cutout relay operation, I'll be considering the DC generating system of small aircrafts. Okay, it is used in several small planes. So let us start friends. So the topic is reverse current cutout relay. So let us understand how does the reverse current cutout relay provide protection in the circuit. Suppose this is a DC generator. Okay, I am writing G stands for generator. One terminal of the generator is this one, which is grounded. Okay, and this is the other terminal of generator, which is positive terminal. Okay, so I am extending this positive terminal. Okay, and in these terminals of the generator, positive terminal and negative terminal, obviously we will have a field winding here. Suppose there is a shunt field winding of the generator. One terminal is connected here, another terminal which is connected to voltage and current regulator. Okay, so friends, about this explanation, how is the voltage regulation done for DC generators using voltage and current regulator, I have already prepared a video in which the name of the topic is vibrating contact type regulator. For this, I'll be sharing the link below, okay, in the description. Do check it out. In today's session, as you know, I'm going to discuss about the reverse current cutout relay. So I'm going to highlight only that part. Okay. So as you know, friends, this is the positive terminal. This is the other ground terminal or negative terminal. So this positive end of the generator is connected to a relay. Okay, and that relay consists of a core. So I am drawing a core over here. Suppose this is the core of that relay. Okay, this core of the cutout relay consists of two types of windings. One is called as the shunt winding or voltage winding, and the other one is called as series winding or current winding. So suppose this is the shunt winding on this core of cutout relay. So shunt winding, these will be made of thin wire, okay, and it will be having many turns. I mean to say, the shunt winding is of the type in which there are many number of turns and is of thin wire type. Okay, so one end of this shunt winding is connected to this positive terminal of the generator. So this positive terminal, you can see it's going like this, and it is connected to this one end of the shunt winding. The other end of the shunt winding obviously will be connected to the negative part, that is the ground. That means this shunt winding is connected in parallel with the generator, right? Next, the other winding which we have on this core is, as I have told, series winding. So series winding, suppose this is a series winding. So series winding will be made of thick wire and few turns will be there. I will repeat again, the series winding is made of thick wire and it is of few turns. So the series winding is also connected to the output of the generator. So I am connecting this output of the generator to the series winding as well. So this is how it is going. Okay, and the other end of this series winding is connected to an armature. Okay, so I will draw an armature over here. So suppose this is the armature plate here. Okay, so this armature is connected by means of spring to the mounting. Okay, suppose there is a mounting on the frame or structure. So this spring holds this armature in a particular position. I'll just extend this armature like this. One end of this armature is connected to a contact. Suppose there is a metallic contact, another metallic contact is here. Okay, and this metallic contact which I have drawn, this one, is connected to bus bar and batteries. So I'll connect this. Suppose this is a bus bar. Okay, and you know, well friends, bus bar is connected to consumer equipments. This contact which is connected to the bus bar, as I have told, is also connected to batteries. So suppose these are the batteries, and it is ground. Okay, so this is a battery. I am closing this within a dashed line. Okay, so this is a battery. Okay, and this is a switch which will be there in the cockpit of the small aircraft, which is called as the battery switch. Okay friends, so this is the switch. So in cockpit, when this switch is closed, whatever current would be coming in this, it will go to the battery also, in addition to the bus bar. Okay, so friends, what I have told you as of now is we have a generator and there is a shunt winding of the generator. And right here, shunt field winding. Okay, and what is this? This is the core having two types of winding. This is the shunt winding and this is series winding. So I'll write here shunt or voltage winding. Okay, and this is your series or current winding. Okay friends, so friends, as of now you're knowing that we have a generator having positive terminal, negative terminal, and the generator field winding obviously is connected to some regulators like voltage regulator and current regulator, which I am not explaining in this, and for that I'll be sharing the link below. As of now we'll be explaining about the cutout operation, that is a reverse current cutout relay operation, which is this one. And to explain that, I have connected the cutout relay in the circuit of the generator. How is it connected? Positive end of the generator is connected to the cutout relay like this. How is it connected? You can see the shunt winding of the cutout relay is connected in parallel with the generator. So you can see there is a shunt winding, there is a generator, they are in parallel. And series winding, you can see it is connected in series with the circuit like bus bar and batteries if this contact is closed. So now friends, let's start discussing about the operation of the system. So whenever the system is in static conditions, that means when generator is not running, at that point of time this contact which is with this armature will be opened. I mean to say, these two contacts will not be contacting each other or will not be closing. Okay, I mean to say they will be open. And why this is open? It's all because of the spring force. This spring force is making sure that this armature is pulled downwards, so that both of them do not make the contact in static conditions. Okay, now next case, when the generator is operating. So when generator is operating, obviously friends, it will be developing a voltage. As the voltage increases, there will come a point where the voltage of the generator will be greater than the voltage of battery, right? So at that point of time, what happens is the current which is flowing in the shunt winding, it will produce sufficient magnetic field. How friends? Whatever the current would be flowing in this winding, okay, that current will produce a magnetic field. That means the shunt winding will produce a magnetic field. That magnetic field will electromagnetize this core, so that the core will behave like a magnet now, or electromagnet. So that magnetic force will pull this armature upwards. That means this contact and this contact will be closed now. Okay, so they will be closed. So when this closes, the supply which is coming from the generator, it will be given to the bus bar and battery. So as you can see here, the generator supply is coming like this, and by means of this winding, since this contact is closed, it will go to the bus bar and battery. All this is happening because of the sufficient magnetic force produced by the shunt winding, okay, which causes the armature to close, and upon closing of these contacts, the current routes to the bus bar and battery. Okay friends? Also you can see that friends, as the current is going to the bus bar and batteries via the series winding, that means the current also flows to the series winding. So it also produces a magnetic field. The magnetic field which is produced by the series winding that magnetic field aids the magnetic field of the shunt winding such that both the magnetic field will cause the core to be electromagnetized in a more stronger way. So this causes the armature to be held close or firmly closed. So this is an assurance, because of the magnetic field of the series winding aiding the magnetic field of the shunt winding. Okay, so in that case, what we have learned is the current will flow to the bus bar and the battery. Okay, so this is the case when the generator is running. So friends, as of now we have discussed the cases when generator is in static condition, and after that we have discussed about when generator is in operation. Now the third case, suppose the generator is shut down. That means we have shut down the generator. So in that case, what will happen? Or suppose the generator is developing a lower voltage at its terminals. So in that case, what happens is, as the voltage of the generator is decreasing because of the generator being shut down, the voltage will reduce and it will reach a value which, if we compare with the battery, will be lesser. That means the generator voltage will become lesser than the battery voltage. As we know, friends, current always flows from higher potential to lower potential. So same thing is happening over here. So the battery current will momentarily flow in the reverse direction, like this, in this reverse direction. Before it was going in this direction, normal situation, but now it is going in reverse order. Okay, like this, in reverse direction. So what will happen? So friends, as the battery current is flowing in the reverse direction, it will produce a magnetic field in the series winding, and this magnetic field will be in opposite direction to the magnetic field which is there in the shunt winding. So because of this, the core will be neutralized and hence the armature will be pulled back by the spring. Hence these contacts will open. Okay, so as this contact has opened, battery current will not be able to go towards the generator. Okay, and that's how the system has been automatically cut off. Okay, so hence it is called as the reverse current cutout relay. That means whenever the reverse current is flowing, the cutout relay will cut out the flow of reverse current to the generator, and hence the circuit will be prevented. Otherwise, if this would not have happened, suppose this contact did not have opened because of some problem, maybe the current would have traveled in this side. So in this case, it would destroy the generator, it would demagnetize the generator. Okay, and this thing is called as the motoring effect. Motoring effect, why friends? Because you know what is a motor? Motor means unit in which if we give electrical power, it will provide a drive. Okay, so here battery is providing you the electrical power at this generator, and as you are giving this supply to this generator, there are chances that the generator would be operated like a motor. And what would happen is, since this current is in the reverse direction, it would demagnetize the generator. So this would damage the generator. Hence, this is a very beautiful thing, friends, that the reverse current cutout is installed in the circuit, and this has cut off the flow of reverse current to the generator. Hence, the motoring effect is prevented and the demagnetization of the generator is also prevented because of the presence of this reverse current cutout. Okay, that's why we say that, friends, the reverse current cutout relay provides protection against reverse current. So friends, whatever we have discussed today, I'll quickly summarize the topic. So we have discussed first that how is the reverse current cutout relay connected in the generator circuit. So we have a generator having a shunt field winding which is connected to the regulators. Okay, and about the regulator, I've already made a video for which I'll share the link below. And if this generator is having a positive terminal and a ground terminal, the positive terminal is connected to the shunt field winding, okay, which is connected in parallel with the generator. And you can see the series field winding is also there, which is connected like this via the armature, and via the contacts, if closed, it will be connecting to the bus bar. You know, well friends, bus bar is, if it's having the supply, it can be given to the equipments, electrical equipments, that is the consumer equipments, and this supply will also be routed to the battery for its charging. After that, we have discussed how is the system operated. Initially, when the generator is in static conditions, means when it is not in operation, at that point of time, what if you observe this armature, it is dominated by the spring force. That means these two contacts will not be touching each other. That means no contact will be established. Okay, that means no supply is going to the bus bar and the batteries. After that, we have discussed the second case where the generator is in operation. So when generator is in operation, obviously it will be producing some voltage, and the voltage, when it is increasing and reaching a value where its level or magnitude is greater than the battery voltage, what will happen is the current will start flowing in the shunt winding. and whatever current would flow through the shunt winding, it will produce a magnetic field. That magnetic field is sufficient to electromagnetize the core and also sufficient to attract the armature upwards. So as the armature is attracted upwards, the spring force will not be dominating in that case, the electromagnetic force will be dominating. So this contact will come in contact with this contact and this circuit will be closed. Hence, whatever the current will be flowing now will flow by means of the series winding to the bus bar and the batteries. Okay. Now, this is what happens when the generator is running. Okay. After that, if suppose we are shutting down the generator, so when we are shutting down the generator, what happens is, friends, the voltage of the generator will be decreased. And if we see the battery voltage at this point of time, the battery voltage would be more, right? I'm drawing an arrow which is upward, means higher voltage. So that this side will be having a higher voltage and this side will be having a lower voltage when the generator is in the shutting down state, right? So momentarily what will happen is, friends, a current will flow from the battery, that means from this side to this side. So the moment this current starts flowing, okay, the current is in the reverse order. This current is called as the reverse current. This reverse current, what it does is, when it is flowing through the series field winding, it produces a magnetic field which will be in opposite direction to the magnetic field of the shunt field winding, and because of this they will neutralize, and hence the core is neutralized. And because of this, now the armature will not be pulled here, okay, will not be pulled to close these contacts. In this case, the spring force will dominate and pull it down, okay, because of the reverse flow of current. And when this happens, this contact opens, the reverse current can go to the generator, and hence we say that the motoring effect of the generator or the demagnetization of the generator field winding because of the reverse current getting to it is not happening. Okay, that means the motoring effect and the demagnetization of the generator field winding is prevented because of the cutting off of the reverse current by means of this cutout relay. Okay, otherwise, friends, you must have observed that when the generator was in operation, the magnetic field of the shunt winding and the magnetic field of the series winding, both of them, they were assisting one another and making sure that this armature is firmly held in a closed position to supply the bus bar and the batteries. Okay, and after that, so friends, that's all about the reverse current cutout operation. I hope you have understood this topic, and I'll come up again with a new topic in my next session. Till then, you enjoy learning this topic, and thank you.